Guys, so I'm going to talk about Android Jetpack Compose today. So before I start, I'm just going to start with a little bit about myself. I'm Yashika. I work as an Android developer, and I've been an Android engineer for like past 5 years. I've been working at Delivery Hero in Singapore, and also a full stack engineer. Some languages I like to play with. You must see on my stickers that I'm playing with Golang recently. Okay, so before I start with Android, I would like to know how many of you are actually aware of it. Have you guys ever built an app? Build an app. Okay, awesome. So I'm just give you a little bit intro about what is Android. Android is open source Linux software, a platform where you can run softwares for your mobile. Pretty simple and a mouthful. In simple words, you can run apps which you use every day on your phone. So today specifically, I'm going to talk about the UI toolkits, the UI that the user are using, the UI that user are seeing every day, the animations, the motions. So how does that work in Android? So this is a little bit of history. I hope you guys can see it. Visible? Okay. So 2008 was when the first Android was started. They started with 1.0. This is the UI history. So they created only one kit in 10 years. And in that one kit, they updated it, they modified it, they made changes, they upgraded it, but they never changed it. So, well, because it's too much of work, obviously. So this was the first phone on the left, the Android phone. I don't know you guys have ever used it or what. It's no one has used it. Quick configuration. It was 1 core, Qualcomm, 528 megahertz, and 256 MB internal RAM. Wow. I don't think we can survive with that today. And this is what we are doing these days. So the UI kit was developed for this small little phone, and it's been used here in this one. So the changes they have made over the ages is made them possible to do this, but not in a better way. Because we started with 1 core, now we have 4, we have 8, we may be expanding it much more. So the community spoke, and the developers were like, dude, you need to change this. Because this is a bundle UI kit. They take 1 year to create a new Android. The 1 year to update the files for the developers. So the UI, if you know there's a bug in the app, if you know there's a bug in Android, you can make a wrapper, you can fix it, but you cannot actually fix it and 1 year later, Android comes and say, hey, we have fixed it. And we're like, nobody cares because we've already done it. We have found a workaround, right? The UI kit was designed for 2008 devices, which we have already realized. It's totally not scalable. The classes that exist right now, they're in Java. They have close to 30,000 lines of code, which I think all of us know that is not a scalable product. And everything is tightly coupled. If you guys know about MVP, MVVM, you would know. These are the design patterns that we use. So why we needed a new toolkit? I'm not saying that what I'm going to talk about is the optimum toolkit. We're going to come back to that. But we do need a new toolkit for Android. So every platform release and the UI releases should be independent. They should not be linked together because I should not wait for 1 year for my new UI. Because user want rapid things, you would want an animation in your phone, right? You would want good motion, you would love it. Everybody would love it. So, and as a developer who wants to build apps, they would want these features in their phone. So I would want an unbundled. So they started with that, okay, so Android started with like, okay, we'll move some of the classes to the library. We'll not make it native, we'll make it helpful for you. But then they realized, okay, if we're doing that much work, if we're making that much effort, why not just make it a little better, So they came to Jetpack Compose. Coming back to that later, the reason one of that was, I don't think this is visible. So in Android, you have to have resources. And this is the amount of resources that you need to build an application that is production ready. You have different layouts, different configurations. You have landscape, you have portrait, you have so many things. And this is just for mobile. You can have for TV, Android TV, you can have for multiple things. So this can go on. And obviously there's VR also nowadays. You would want your app to be on VR. Okay. So then they created this Jetpack Compose. So they said that we'll create something new, something fresh, and they don't use any Android native libraries. It's completely written in Kotlin. It's inspired by React. If some of you has used React, it's a Flutter, Vue.js, these kind of languages. So quick benefits, I think it's a modern toolkit, simple UI design, written in Kotlin, so very less code. It has composable functions. We will definitely come back to that. Obviously, each composable defined by composable, again, we'll come back to that. It has separation of concerns. So each UI component is individual from the other one. Nothing is dependent on each other, unlike the previous Android toolkit we had. OK, and obviously, it makes view rendering fast. That's the goal. That's the goal. We want you to view your app fast. Second of all, this is still under progress. Nothing is production ready. They're still working on it. And it's open for contributions. So yeah, that's it. This would be difficult to watch. So this is the button class that they had. This is a simple button that you see on your Android phone. You might not think this is a very simple thing. You just place a button. But it has like a 12,000 line code written for it in Java. And that's just a, 10 lines in the new toolkit. So this is what they moved to this one in the new toolkit. They didn't want. So why does a button need a text view, right? It extends the text view. Do you want your button to be selectable? Do you want your button to be changed? Can user select a button? Text selection? No, right? You just click on a button, right? So I don't think that's necessary. So they removed all this shit and moved to something cool. OK, these are the same thing. I think that's the XML one that's been previously used. So you just write, this is what the XML creates, a login button. And similarly, this two-liner creates the same thing. And this is our new toolkit, and that's the old one. OK, a bit deeper. So composable, you can create your own UI element. OK. So what I want to do is this image and two text. I want to make this as a UI component. So I add @ composable on top of it, and that's it. This is my new UI component. And I can customize it as I like. I can change the height. I can change screen size. I can add constraints based on the layout that I'm using, landscape, portrait, anything. You don't have to worry about the resources anymore. Now, the fun part is what's happening inside. So everything has a runtime compiler, right? Java has JRT. Android has ART. Compose basically has Compose runtime. So it's independent of any other tool that Android uses. It's not linked to Android device. It's not linked to anything. So it uses Compose runtime. So whenever you write @ composable on top of your function, also before little come back, I want to say that all UI is a function here. In Compose, every UI element is a function. So button is a function, text is a function, everything is a method. So it's very easy to implement. So most likely using Kotlin as a functional language, it's been targeted as that. So whenever you write @ composable with your function, you will think that this is an annotation, and they're going to be annotation processing. But no, that's not it. This is not what it's doing. It's actually a Kotlin plugin. It defines a function in a certain way. So it's not processing anything. It's not an annotation. It's just saying that this function does a UI part. That's it. So internally, it uses data structures, which is obviously everything. So I don't know if you guys know about gap buffers. Gap buffer is a type of data structure in text editors, notepads. What it does is always have extra space in his array, more than the elements that they always have. So that extra gap, that causes the gap buffers. So composable uses those gap buffers data structure to define and create components for Android readability. So when you write in your compose, it converts to Android readable Android compose view, and then it is painted as a canvas to the UI. So internally it does this, and a lot more complex, too many classes to be created. So coming to the drawbacks. So I said that this is not, we need a new toolkit, but I don't think this is the right one to go with. There are many controversies, because when you move from XML to a Java and a Kotlin code, people have been working here for 10 years, okay? People have been working in Android for over a decade. So you're too comfortable, you don't want to move, right? You know, and you never even thought that there was a gap. You never even thought that there was a gap in creating UI, right? You thought that, oh, this is the way to do it. This is how, this is how all the guidelines say. This is how the YouTube videos say. So this is the way to do it. But you never questioned it. So it's very difficult to change the mindset of people that we need a new toolkit, more than just creating one. So again, you don't need, so the problem is it's not standardized. People will definitely mix business logic with the UI logic, which is so not recommended. And there are going to be a lot of problems with the coding styles, all the other things. So, and Android currently has drag and drop. iOS has drag and drop, all these things. I think .NET has drag and drop to view the views, but Compose does not. So I don't know what's the future for that, but hopefully they do, because we would want our developers to be more proactive about creating UIs. Okay, that's it. Thank you guys.